This is a tutorial for how to reannotate a mitochondrial gene. In this example, I will be using the NAD3 gene. Throughout this process, you will need a couple of different materials in order to complete the reannotation and properly record your results. As you can see here, I have pulled up the Exposé Translate webpage, my table for my final annotations, the Mega software with the full mitochondrial genome, the text file for the genes compiled by Mitos, and a new text file for my finished sequences. First, I am going to go through the file from Mitos and find my gene of interest, noting where Mitos has denoted its start and stop. I am then going to copy this sequence and put it into the Exposé Translate tool, making sure that the settings are on verbose and invertebrate mitochondrial. Once I have translated this sequence, I can now scroll down to see if I need to correct the start or stop codon locations for this gene. Exposé has found a start codon, which I will double check to make sure that this follows typical start codons known to be in these mitochondrial genomes. In order to find the correct location of the stop codon for this gene, I will start where the current sequence ends, which is given to me by the numbers above the sequence on the Mitos file. After finding the location in Mega, I will then begin to copy the codons directly after this sequence and paste them into Exposé in order to see if there is a stop codon within the copied sequence. As you can see, I have found a potential stop codon, but I have copied a little bit too far. This is where I will then go back to the sequence and remove the extra codons in order to find where the correct location of the stop codon is. A good tip is to pay attention to the location which you started at and you copied to in order to find the correct location of your start or stop codon. Once I have found what seems to be the correct and complete sequence, I like to double check by removing the last couple nucleotides in order to ensure I have found the correct full codon. Now you can compare your sequence to the Mega file to find the numbered location of your stop codon. These can then be put into your table of your final annotations. As you can see, I have recorded both the start and stop location, as well as what each start and stop codon is for the particular gene. Finally, you'll want to copy this final sequence and put it into the text document you created that will eventually contain all of your protein coding genes. Here are a few tips for you to reference while working on your own annotations.